So in this video, I'm going to continue my discussion of binomial probability distributions and show you how you can calculate probabilities that are associated with a binomial random variable using a TI84. So recall that in a binomial probability experiment, the number of trials is fixed. And before we get into the calculations, I want to introduce some notation. The number of trials we call n, and the probability of success in any given trial, we call that p, and x, our random variable, is the number of successes in n trials. So, all right, let's say that we have an experiment where we have a probability of 0.40 of success, so that's our p, and we have a trial or n trials, and so automatically I know that my random variable x can take on values between 0 and 10. So this would be 0 successes, and I can have up to n, which is 10 successes. So if I want to construct a probability distribution, I would need a table which includes the possible values of 0 up through 10. So I'm going to use my calculator to fill in some of the probabilities here. So in a TI84, there is a menu for various probability distributions. To access that, you'll hit your second button and then this variables key. So then scroll down, and what we're looking for is binomial PDF. So BINOM PDF. And be careful, because just underneath that there is a binomial CDF function, and we'll talk about that more in just a moment. So if I select this, your calculator, depending on the version, you may have prompts. If not, you're going to have to create a list with the different arguments for this function. The arguments will go in this order: n for the number of trials, p the probability of success on a given trial, and then how many successes in n trials. So for instance, if I want to find the first probability here using these values, there are 10 trials, comma, probability of success is 0.4, and to fill in the first one, I'm interested in the probability of 0 successes. So I find out that this is 0.006, and I'm just going to keep 3 decimal places here. And I could continue on, each time just changing that last value, so that in the next time I would change it to 1, and I would repeat that. It would take a total of 11 times, and finally I would get the probability of having 10 successes in the 10 trials. So I'm going to show you a shortcut, though, using my stat menu. Here's my list menu. I'm going to enter the values uh, 0 through 10 in list 1, and I want to fill in all the probabilities in list 2, and I can do that with one move. If I move my cursor up to the L2 column header and then go back to that distribution menu and find the CDF function, binomial CDF. So notice that that has populated here. L2 equals the binomial CDF, and the first argument, that's 10 trials with a 0.4% chance, well, it's a 40% chance, or a 0.4 probability. And the third argument, these are the number of successes. Those values are found in list 1. So if you have the prompts, you would just hit 10, 0.4, and L1. and then hit enter, and it should populate list 2 with all of these probabilities. So you see 0.006, the next one is 0.046, and then 0.167, 0.382, 0.633, 0.834, 0.945, and actually I just realized I've made a mistake. 1 second. I want to go back to my instructions here and hit my distribution. I think I chose CDF instead of PDF. I want CDF, and 10, comma, 0.4, comma, list 1. Let's try that again. Oops. Oh, that should be list 1. Okay, that looks better. This is point. Sorry about that. Alright, so this is 0.040. I'm not going to write all these down. Those values are available in the calculator. Okay, so if now that I have all of these values calculated, if I want to know the probability that in these n trials I would get maybe 3 successes. The notation I would use for that is the probability that x equals 3. So that would be exactly 3 successes in n trials when the probability of success is 0.4 for any one trial. So to find that probability, I can just look in my table across from 3 and find that that is 0.21499, so I'll just say 0.215. If I want to know the probability that I would have exactly 9 successes, then I could just look down in the row with 9 and see that that is 0.00, and then I'll round to 2. Okay, so the binomial PDF function tells me the probability that my random variable takes on a particular value, and that could be any of the values between 0 up to n, so which would mean all successes. Okay, so now let's talk about that mistake that I made a moment ago and where that comes in handy. Sometimes I want to know maybe the probability that x is less than or equal to 3. So that would mean that my random variable could take on any one of these 4 values, 0, 1, 2, or 3. Now, of course, I could just add up these probabilities to answer this question, but there is a shortcut using the binomial CDF function. So I'm going to go to column 3 here, move my cursor up to the column header, and this time I'm going to choose the binomial CDF with the same arguments. There were 10 trials, a 0.4 chance of success on a given trial, and my values of x again are in list 1, and then that's what I mistakenly did the first time in list 2. So what do we notice here? In the first row, when I'm talking about the probability of 0 successes, I see the same amount in list 2 and list 3, 0.006. But from there on out, the values differ. I want to scroll down to the last row where there's a 10. So in L2, I have 1 times e to the negative 4. 1 e negative 4. A little sidebar about what this means. That's 1.0 times 10 to the negative 4th, which means I actually need to move this decimal back 4 places. 1, 2, 3, 4. In other words, stick 3 zeros in front of that 1. So that's what this means. So in L2, I have 0.0001, and in L3, I have 1. L3, where I have the CDF, that's the cumulative probability. So in other words, it's keeping a running total of all the probabilities up to that point. So in the first row, there's really nothing to accumulate, so we're seeing the same values in both, 0.00605. But when we look to the last row, these have accumulated all the way to 1. That's the total of all the probabilities that you're seeing in list 2. All right, so if I want to know the probability that x is less than or equal to 3, I can look in the 3 row, and I'll see that that is 0.382. Let's discuss a few more other types of questions that we can answer. What if I wanted to know the probability that x was strictly less than 3? In other words, that's the probability that x equals 0, probability that x equals 1, plus the probability that x equals 2. So it would be any one of these strictly less than 3. You can add those up, or we can just look over here in the 2 row and find that that's 0.16729. Let's think of some other possibilities. What if you wanted to know the probability that x was greater than 3? So greater than 3 would mean that x could take on any of the values from 4 all the way up to 10. Again, you could add up all the probabilities that you find in the PDF column, but I think the easier thing to do is to use our complement rule. The probability that x is greater than 3 is 1 minus the probability that x is less than or equal to 3. So this group. And so that's the value that we found right here. Less than or equal to 3 is 0.302, so 1 minus 0.382. 1 minus 0.382, that's 0.618. Let's see. Another option would be, what if you wanted to know the probability that x was in between two values, inclusive? So between maybe 2 and 8. When I say inclusive, I mean it could be equal to 2 or equal to 8 or any value in between. So in this case, I'm looking for the probability that x takes on one of these values, between 2 and 8 and including 8. So there are several different ways that you can do this. Always, you could just add up, the probabilities in the PDF column, but you'd have to add up 1, 2, 3, 4, 5, 6, 7 values. I think an easier option is to say, well, that is the entire group up to 8, but then taking these away. So if I take the CDF for 8 and then subtract the CDF for 1. So basically, initially I'm taking the accumulated probability all the way up to 8. But I realize that I really just want the values between 2 and 8. So then I'm subtracting off the probability here at the low end that includes 0 and 1. So looking in my list here, the CDF for 8 is 0.99832, and if I go back down to 1, it's 0.04636. So if I subtract 0.99832 minus 0.04636, that's 0.95196. And again, you would get the same answer if you were to add up the probabilities between here and here in this PDF column. Okay, so that's how you can use your calculator to get binomial probabilities and either the PDF or the CDF. Okay, I'll hope you'll join me in some follow-up videos where we do some examples using these concepts and our calculators.